A 10-year-old girl sat down and wrote a letter. Not to a friend, not to a relative, but to NASA itself. Her request was simple. Give Pluto its planet status back. What happened next surprised almost everyone. On April 9, 2026, NASA Administrator Jared Isaacman confirmed the agency was actually looking into reinstating Pluto as a full planet. But here is the twist nobody expected. NASA cannot make that call alone. The final word belongs to the International Astronomical Union, the very body that stripped Pluto of its planetary crown 20 years ago. So a question that seemed settled has been reopened, and the debate is burning hotter than ever. What is it about this small, frozen, distant world that refuses to let go of our imagination? To understand why grown scientists are once again arguing about a rock 5.9 billion kilometers from the Sun, we need to travel back through Pluto's entire story, and through the story of the object that started this fight in the first place, its enormous companion moon Charon. Nitrogen dominates Pluto's surface, making up 98% of everything visible. Nowhere is that clearer than in the giant heart-shaped feature named Tombor Regio, honoring Pluto's discoverer Clyde Tombaugh. Its western half, Sputnik Planitia, is a smooth basin of frozen nitrogen, while its eastern half is rougher, pitted like the surface of an orange peel. Researchers believe wind currents lift nitrogen out of Sputnik Planitia and redeposit it onto the eastern uplands, brightening that terrain considerably. Some of that material then slides back down through slow glacial creep, forming an ongoing cycle between the two halves of the heart. To the west of Sputnik Planitia stands the Ullidrisi mountain range, where thin winds drag grains of methane ice against the peaks, most likely lifted by sublimating nitrogen ice changing directly from solid to gas. The result is a 2,000 square kilometer dune field, visually similar to Earth's Taklamakan Desert, yet forming in conditions near -230 degrees Celsius. Nearby, a deep trench runs alongside the range, with mountain peaks growing progressively taller the farther they sit from that trench, some reaching nearly 3 kilometers, comparable to the Rocky Mountains. A 2019 study presented at the Lunar and Planetary Science Conference proposed that these mountains have gradually shifted eastward through solid-state convection, a process that would only make sense if a layer of liquid water exists beneath Pluto's icy shell. That single detail reopened a much bigger possibility, that Pluto might harbor a hidden ocean, much like the moons Europa, Enceladus, and Ganymede. Adding weight to that idea are two towering structures, Wright Mons and the even larger Piccard Mons, both bearing wide central depressions resembling volcanic calderas. Scientists have not confirmed them as true cryovolcanoes, but the evidence pointing that direction keeps piling up. None of this explains why Pluto lost its planetary status. For that, we travel back to June 22, 1978, to an astronomer named James Christie at the United States Naval Observatory, quietly sifting through old photographic plates of Pluto to refine its orbital path. Several of those plates had been labeled poor or defective, because Pluto appeared not as a clean point of light but as a smudged, lopsided blob. Most researchers would have dismissed the flaw as equipment error. Christie did not, because years spent photographing double-star systems had trained his eye for exactly this kind of pattern. He noticed something the earlier observers had missed. The background stars on those same plates were perfectly sharp. Only Pluto looked distorted. That meant the problem was not the telescope, it was something physically there. Digging through the observatory's archive, Christie found the same elongation on plates dating back to 1965. Working with colleague Robert Harrington, he tracked how the bulge shifted position across the years and discovered it circled Pluto once every 6.4 days, matching Pluto's own rotation exactly. Pluto had a moon. Christie named it Charon after his wife Charlene, adding the suffix used in physics for particles like protons and electrons. Only afterward did he learn the name already existed in Greek mythology, belonging to the ferryman who carried souls across the river into the underworld ruled by the god Pluto. The International Astronomical Union formally adopted the name in 1986. Charon's discovery let astronomers finally calculate Pluto's mass using its gravitational pull on the moon. The number was shocking. Pluto turned out to weigh roughly 1/6 as much as Earth's own moon. Charon, meanwhile, carried about 12% of Pluto's total mass, an extraordinary ratio compared to Earth's moon, which represents barely 1.2% of Earth's mass. Because the two bodies are so close in size, their shared center of gravity, or barycenter, sits not inside Pluto but in the empty space roughly 960 kilometers above its surface. Both worlds are locked in mutual tidal synchronization, meaning Charon always shows Pluto the same face, and Pluto always shows Charon the same face in return, an arrangement almost unheard of elsewhere in the solar system. This strange partnership fueled arguments that Pluto and Charon were less a planet and moon and more a double-planet system. The International Astronomical Union even weighed a formal double-planet classification in 2006, before ultimately setting the idea aside in favor of a much bigger decision, demoting Pluto entirely. That decision did not come out of nowhere. Astronomers were discovering other distant bodies beyond Neptune, objects like Quaoar, Sedna, Makemake and Eris. Eris was initially believed larger than Pluto, though later measurements found it slightly smaller in diameter while still being more massive overall. If Pluto counted as a planet, did all of these newly found worlds count too? To settle the confusion, the International Astronomical Union drafted 3 requirements for planetary status. An object must orbit the Sun. It must have enough gravity to pull itself into a round shape. And it must have cleared its orbital neighborhood of other debris. Pluto satisfied the first 2 conditions easily, but failed the third, sharing its orbit with numerous other bodies it never swept away, including objects called Plutinos like Orcus and Lempo. That single failure was enough to reclassify Pluto as a dwarf planet. How did Pluto and Charon end up bound together in the first place? Early models borrowed from the theory behind our own moon's formation, proposing a violent collision between a Kuiper belt object and a young Pluto, with debris later gathering into Charon. That explained the system's momentum and Charon's near-circular orbit, but it struggled against a growing problem. Pluto and Charon are rigid, icy, rocky bodies, nothing like the molten young Earth involved in our moon's formation. A newer model suggests something gentler, a slow grazing collision, almost a cosmic kiss, where the two bodies briefly fused into a spinning snowman shape before tidal forces pulled them apart again, leaving them gravitationally bound but structurally distinct. This idea fits observed differences in composition, with Pluto being about 70% rock and considerably denser than Charon, which is closer to 55% rock. The heat unleashed during that impact and subsequent separation likely melted ice deep inside both bodies, setting the stage for everything that followed. When New Horizons finally revealed Charon up close, it showed a world torn apart by its own history. Vast tectonic fractures stretch across its surface, including a massive equatorial canyon system at least 1,800 kilometers long and up to 7.5 kilometers deep, several times longer and deeper than the Grand Canyon. These canyons were not carved by water flowing across the surface. They were created from the inside out. As heat from Charon's violent birth melted the ice within, a subsurface ocean formed. Over millions of years that heat radiated away and the ocean began to freeze. Unlike most substances, water expands as it solidifies, and that expansion pushed relentlessly against the surrounding crust until it finally cracked open across the entire moon. The northern hemisphere, nicknamed Ounce Terra, preserves this ancient fractured terrain in full, heavily cratered and scarred. The southern hemisphere tells a different story. Vulcan Planitia is a smooth, young plain, formed when pressurized water mixed with ammonia forced its way up through the newly opened cracks and flooded the landscape in icy slush, a process known as cryovolcanism. Scattered across this plain sit isolated peaks like Kubrick Mons, thought to be chunks of older crust carried along like icebergs before becoming stranded as the flows froze solid. Perhaps Charon's strangest feature sits at its north pole, a dark reddish stain informally called Maunder macula. Like Pluto's dark regions, the color comes from tholins, but scientists still debate where the raw material came from. One theory holds that methane escaping from Pluto's thin atmosphere drifts across space and gets captured by Charon's gravity, freezing onto the pole during its century-long polar winter before ultraviolet light converts it into reddish tholins once sunlight returns. A competing theory suggests the methane came from within Charon itself, released during the same cryovolcanic eruptions that created Vulcan Planitia, briefly forming a temporary atmosphere before settling and freezing at the poles. Either way, that red cap stands as physical evidence of a bond stretching across 19,640 kilometers of space. Everything we now know traces back to a smudge on a damaged photographic plate that almost got thrown away. Charon revealed Pluto's true mass, exposed its violent formation, and even helped trigger the very definition that cost Pluto its planetary title. And yet that title may not be permanently lost. Critics of the current definition point out that Earth still shares its orbit with roughly 10,000 nearby asteroids, and Jupiter shares its path with about 100,000 Trojan asteroids, raising an uncomfortable question. If failing to fully clear an orbit disqualifies a planet, should that standard apply just as strictly to Earth or Jupiter? Some scientists now argue that Pluto's remarkable geological complexity, its possible ocean, its ice volcanoes, its dynamic surface, deserves more weight than a strict orbital clearing rule. With NASA's own administrator hinting that the definition could be revisited, the conversation Pluto started decades ago is far from finished. In the end, planetary status is a label humans invented and humans can change. It happened once already. Whether or not the International Astronomical Union chooses to reverse its decision, Pluto and its remarkable partner Charon will keep pulling us back, two frozen worlds locked forever in a slow, silent orbit around each other, and around our imagination.